I'm just going, I don't know what the first one is. I'm just going to hit all three of them. This question, this is a test question. It's a review test question. Just write the question down and we'll go over it with the handy dandy visualizer. Use shifts and scalings to graph the given function. This is exactly the type test question I would give you as far as vertical and horizontal shifts. So what family of graphs is it in? It's in the parabola. And I think we did one like this, only it was opposite. I took a function, turn the oven off. I took a function and I graphed it, and then we took from the graph and wrote it back in intercept form. In this case, we're doing it the opposite way. We're going to draw a graph based on this intercept form. Now, let me remind you, and if you had me for a teacher in 109 and 130, you know what I'm fixing to show you, that there's two different ways to write the vertex. When you're doing completing the square, and you do x squared plus 4x plus 4 is equal to 0, and you x squared plus 4x plus blank is equal to 0 plus blank. Half of 4 is 2, 2 squared is 4. And you get x plus 2 quantity squared is equal to 4. At this point, there's two ways to write the vertex. Now, you 109 and 130 people that's had me before, you know what I'm talking about. You take the opposite of both numbers. That's one way to write it. Opposite of both numbers. So what would the vertex be here? -2, comma -4, Hubert. Thank you, Math 109 and 130 students that had me before. All right, the other way to write it is what we call intercept form. Now, I don't go over this a lot because I really don't like to write it in intercept form, but that's just me as a teacher. And that is bring the 4 back over and put f of x in front of it. So that's going to be f of x is equal to x plus 2 quantity squared minus 4. Now, when you have it in intercept form, you can just take the opposite of the 2, which is -2, and bring down the -4. Either way, do you get the same answer?
Mm-hmm.
Yes, but you got to realize here, what they're giving you intercept form, which is this form right here. So you don't take the opposite of both. You take the opposite of this one, and you bring this one down. And that is a common mistake that's made with students. So in this problem, you've got, I'm going to get another black one. I think that one's about dead. F of x is equal to x plus 2 quantity squared plus 1. Now, do you think that's all I'm going to ask you?
No.
Hell to the no. I'm going to ask you to give me the x and y intercepts also. So right now we've got a vertex of -2,
1,
comma 1. So there's our vertex. Now I want you to what? Now I want you to find the y-intercept. So f of x is equal to, you can actually find the x-intercepts first. So I'm going to find the x-intercept. Let me do this. Let me do x plus 2 quantity squared is equal to -1. The square root of both sides say that there is no x-intercept. So x plus 2 is equal to 1i. And x is equal to 2 plus 1i. So you know there's no x-intercepts. And then we're going to find the y-intercept. So just unfold all of this. And f of x is equal to, shortcut number 1 is x squared plus 4x plus 4 plus 1. F of x is equal to x squared plus 4x plus what?
Plus 5.
Now you can draw your graph. My y-intercept is plus 5. 1, 2, 3, 4, 7. And my vertex is -2. 1, 2. And which way is it pointing? It's opening what? Concave up?
Up.
So it does not. So my domain is all real numbers. My range is
1 to infinity.
is 1 to infinity. Decreasing from -infinity to -2. Increasing from -2 to infinity. Now, if you can do that problem, this problem from here to here, then you're good to go for the test. If you understand everything here, then you're good to go as far as graphing, vertical and horizontal shifts, completing the square, you're good. Good question, whoever sent it. Yes.
The only sort of question I have is, so when you use shortcut number 1 to get f of x equals x squared plus 4x plus 5, what is it that lets you know that the 5 is the y-intercept?
Okay. Back in algebra 2, you were taught the following method. Method 2, intercept method of graphing.
Yeah.
2x plus 3y is equal to 6. You should have been taught, take that and put an x-intercept over here, 0 for y, y-intercept here, and what do you always plug in for y-intercept? 0 for x. That right there is what you should remember. Okay. Whenever, I don't care if you're in Marketing 101, Calculus 5, differential equations, thermodynamics, statics, I don't care what you're in. If you ever want to find the y-intercept, what do you plug in for x?
0.
And if you plug 0 in right here, what happens to these terms?
They cancel.
And you're left with 5.
And you have to complete, or you have to use shortcut 1 in order to get that, because if you plug 0 in for the when it was in the intercept form, yeah, right there, if you plug 0 in for x, what?
Yeah, you wouldn't get it. That's why you have to expand it. It has to be in the form of an equation, of a parabolic equation or a quadratic equation for you to do the y-intercept.
Okay, all right.
Okay, so whoever sent that question, that was a very good question. The reason it was a very good question is because it dabbled in a little bit of every part of the review. It dabbled into polynomials, it dabbles into graphing, vertical and horizontal shifts, domain, range, decreasing and increasing. So that question has about 4 sections in it. That's a good question. Give you like 5,000 of those on the test. Next question. This question is not a test question. I'll tell you why. Because as far as application to calculus, it really doesn't have an application. They're just kind of, I guess they're reviewing to see if you have the critical thinking skills. And I would tell you on this guy to draw a picture. You've got I'm going to call it a pencil box. You know, pencil box, it looks something like this. pencil box. You know, see it on the desk, got pencils sticking in it or pens sticking in it. And the bottom here is x by x. So I'm going to draw a square. This is the bottom. And x by x.
We can't see what you're drawing.
Oh, I'm sorry. You're supposed to have that extra sensitive perception going on. What's up? There you go. All right, so the bottom is x by x because it says that the bottom is a square. So somebody looked that up in the question. I'm not going to look it up, but it says it in the question somewhere. Okay? Now, each one of these sides, and I'm going to color these sides yellow because that's my favorite color. And it's the only highlighter I've got that works. I'm going to color that side, and then you got two more sides. Now, what is the surface area of one of those sides? Well, that's going to be x times what? H. And you got 4 of them. First, we've got to figure out what the height is. Okay? So, the volume, okay, the volume of any three-dimensional object with a rectangle or quadrilateral is equal to, think of the swimming pool. What is it? Length times width times what?
Times height.
Height.
Or base times height times whatever. I don't care what you use. You got to have one that's vertical and 2 that are linearly. Okay? In this case, we know we've got the x times the x, which is x squared. So 137 is equal to x times height. And 137 is equal to x squared times height. And height is equal to 137 divided by x squared. And we're going to keep that in our handy dandy memory bank. So write that down. And now we got to put that in the memory bank because now we're going to do the surface area of the whole, because that's what it's asking for. It's asking for the surface area. So surface area of this guy is equal to length times width of the bottom plus base times height of the sides, right? So that's going to be area, surface area of this pencil box is going to be x times x. That's for the bottom. Plus what? Plus 4 times, well, what's the height? X times what? 137 over x squared. And all you got to do now is just kind of get that, kind of simplify that, and you should come up with x squared. And what's 4 times 137? I don't need the x, I'm sorry. What's 4 times 137? Somebody multiply 4 times 137 for me.
584.
And that's going to come out to be
548. 548, rather. I
plus
misspoke.
what?
548.
548
Yes.
over x squared. That should be your answer. Let's see what they must be another answer in there somewhere. There it is. That should be your answer. And you feel good about yourself. And now they just want you to graph it. I'm not going to graph it. Well, we can graph it. I think I got a graphing calculator on here somewhere. I think it'll come up.
So are we supposed to use calculators for this class or not?
Yes, you can. The only thing you're going to use it for is graphing. Just like that last problem, you'll check it to see if you got it right. And I'm still waiting on this thing to pull up. Why is it taking so long?
Additionally, at Clemson, and you're not allowed to use calculators in Calc 1, so I just was making sure.
Well, I think that's a good thing, but the reason I don't worry about it is because most of the questions I give, you know, you got to be able to, and another reason is a lot of your calculators up there at Clemson now are TI 89s or above, or TI 91s, which they can actually do the calculus. And that's why they kind of, okay, it's not responding. I don't know what's wrong with this. Anyway, if you graph this, somebody graph it on your graphing calculator, because this thing's not working. And tell me which graph you get. Okay, there we go. Okay, it's just taking forever. Good gosh. I think I pulled it up with Rust. Okay, anyway. Y is equal to, parentheses, x squared. So x squared plus, I'm going to put parentheses, 548 divided by x squared, close parentheses, I hate these newer calculators. They don't think. Let's hit delete. Close parentheses, and hit graph. Okay. Oh, my stat plot is on. Second stat plot. Okay, quit. Fine. Go away. Second stat plot. And I need to turn that one off. Turn it off. And y is equal to that, and hit graph. Okay, to draw the graph, and I guess I'm going to have to hit 0 plus, well, 0 is going to give you an undefined function, so I don't know what I'm graphing. Let me do a zoom standard. Zoom standard. This calculator is running very slow. Anybody got it come up yet? Try zoom fit. 0. Anybody got it come up? There it is. So we're worried about the quadrant on the right because what is distance? Distance is always what? Distance is positive. I see you, Miss Patel. Hold on just a second. Distance is positive. So which quadrant is all positive? The first quadrant. Okay, so I'm gonna just go to window, and I'm gonna change it. The x min, I'm going to change to -1. And I hope it don't blow up because this calculator is running like 15 times slow. And the y min is -1. And now I'm going to hit graph. There. Now we're focusing on this side right here, so it should look something like that. And what they're looking for is the minimum, but I don't know. Let's see what they're asking. I really don't know what they're asking. Probably looks like C. I think that's all they're going to ask. No. Well, I don't have any idea what what it is then, because I look. Oh, wait a minute. They're giving you the window size 0 to 25 and 0 to negative 250, or 0 to 250. So go back and change your window. Sorry. 0 to 25. So go to window and 0 to 25. And y'all can do it a whole lot faster than I can. And 0, oops, that's a decimal point. 0 to 250. Okay, there you go. So it looks something like D, let's see, with delta. It's either delta or Bravo. I think it's Bravo. It's delta. And X, let's see, what do they ask for? Is this B? Based on the graph, estimate the value, minimum surface area. So we need the vertex. We should have done this by dadgum. Well, no, that would have caused y'all to blow a gasket. I've done this by completing the square. So let's go back here. Find the vertex. How do you find it? Well, you hit second, trace. We want to find the minimum. Oh gosh, this calculator's running slow. And left bound, just give it an estimate. It'll take me 3 or 4 days to get it down there. I'll get your question right after I get this minimum, Ms. Patel. Left bound. Does anybody know why you give a left bound and a right bound? Does anybody know?
In case there's more than one possibility.
Well, yeah, but they also do it to slow the time down for the mathematical calculation. It kind of narrows the parameter. So that way you're looking in a small window versus a big window. And it helps if you have more than one, like a local min and a local max. Both of those answers. And write this down. Okay, your minimum is 4.84. That gives you a Y of 46.82. So your answer here says round to 2 decimal places. Your X, I done forgot it, is 4.84. So you write 4.84. And that's your minimum surface area. Hell, I don't know what they're asking for. It's 4.84, it might be 4.85. Look at the calculator and see if it's 4.84 or 4.85. $6.5. I have no idea how they got 6.5. Did anybody get 6.5 on their calculator? There's no way. I think something's wrong with that question.
There was another one where you had to round to 4 decimal places and try as you, like, short of blowing it up the window so that you were staring at like 1 pixel's width. There was no way to get it within that accuracy.
I think there's something wrong with that question. Ms. Patel, what was your question?
She's had her hand up since we started.
Oh, I thought
She may have just clicked it and forgot to put it
Oh,
down.
she forgot to unclick it. Okay. Well, go ahead and unclick it, Ms. Patel, unless you got a question. Because I think there's a, okay. Just unclick it if you don't mind. All right. That's not a good question. So I can understand if you had a question about that one. I don't understand how they're getting this one. So I'm going to say B. And this is what you should do. Send it to the publisher and say, how did you get 6.5 for B? How did you get a solution of 6.5 when the vertex is at, what was my 4 point what? That's all right. I'll find it. Don't need to help me out. What?
4.84.
4.84. And just now, I have noticed also, and I don't know if these are new questions. It's the wrong damn answer. If you'll notice, I bet you $1 to a donut hole. This one don't have ask my instructor. I meant help me solve this. Yeah, it doesn't even have ask my instructor. These questions that don't have anything in it, I think they're new or something, because every time I get one of these that does not have that doesn't have anything on it like this one, there's something wrong with it. There's something really wrong with it. So I'm thinking, let me ask, who was that? Well, was that Mr. O'Quinn that said that you had one like this and you couldn't get the correct answer?
Yeah, I had to do it like 3 or 4 times because I had to keep blowing up the window in order to get a small enough approximation for it.
Did it have help me solve this, or did it have just these two?
It just had those two.
Yeah, I don't know if these are new questions or whatever. And I think Ms. Sterling knows what I'm talking about. We had this problem in 130. There's some weird questions. So whoever sent that question, you got a right to be confused. And I'll wait for the verification, but I don't know how you can, when the calculator finds the vertex, I don't care how many times you blow it up, based on your graph, estimate the value of X that produces the box with the minimum surface area. The minimum surface area means vertex, means the min, the vertex. And there's no other vertex for this function unless I've typed the function in wrong. And I typed in this function, did I not? Did I not type that in right there? I thought I did. Yeah, I did. So, I don't know. We'll wait for that answer to come back, okay? Anybody got any input on this one? All right, let's move on. Okay, this question is sent, and the reason I'm including it, I answered the question, but I can understand why you're wondering about, okay, the question was sent to me, and the question was asked, why aren't we rationalizing the denominator? Okay, when you're dealing with trig functions, you don't fool with the denominator as a radical, and I'll tell you why. In Calc 2/3, I'm putting this on my writer. In Calc 2/3, when you get to Calc 2 and 3, you're going to be recognizing trig functions with the radical in the denominator. Now, my 109 class and my 130 class and my 110 class, I always tell students, calculus and radicals don't mix. But when I say that, I'm saying it with the basic functions, okay? Calculus and radicals don't mix. And when I say that, I mean with the basic derivatives and antiderivative functions. That does not include trig functions. If you get a radical in a trig function and it has an x under it, you just leave it alone. Leave it alone. Because later on, you're going to see that's going to tell you it's going to be the derivative or the antiderivative. So in this case, this problem, I'm just going to cover this up because I don't want you to see that right where we're doing it. It says express theta in terms of x using the inverse sine, inverse tangent, and inverse secant functions. Okay? Well, first of all, you just draw the picture. And you got theta right here. So your little man is standing right here, and the little man has his foot on the adjacent and the what? The hypotenuse. So therefore, the opposite is right there. The opposite is x, and the 5 is the hypotenuse. Now, right quick, I'm going to go ahead and use the Pythagorean theorem, and I'm going to get a, so I can fill in everything. So let's see. C squared is equal to a squared plus b squared, and c is equal to, I don't need c, I need a. So I need to go, okay, a is equal to c squared minus b squared is equal to a squared, and a is equal to the square root of c squared minus b squared. Okay, so what is 5 squared?
25.
So that's going to be the square root of 25 minus b squared. That is a. And now you just go back to your basic trig functions, and it is the inverse. Oscar had, well, that's going to be Oscar had, but the inverse sine, yeah, that's going to be the sine of theta. Yeah, that's right. So that's going to be the sine, and I'm going to do this for you. So A is going to equal sine of theta is equal to Oscar x over 5, Oscar had. Theta is equal to x over 5 divided by the sine. That's to the first power, so when you bring it up, theta is going to equal the inverse sine of x over 5. And you do that with each trigonometric function. Oops, I'm sorry. Hold on. Pull that up. So you do the tangent. So B, I'll write it out for you. B is equal to tan of theta. Oscar had a hunk of what? Oh, Hubert, I didn't learn that. I learned Sakatoa. Shut up. Oscar had a hunk of apple. Okay, so let's go back to our handy-dandy picture. What's opposite? Opposite is x over adjacent. Okay, so that's going to be over the radical. So that's going to be equal to x over square root of 25 minus b squared. So divide by tangent. Divide by the tangent.
Mm-hmm.
Theta is equal to the inverse tan. Bring that up. That's a 1. Bring that up. It's inverse tan of x over 25 minus b squared. All right, now you do the secant. Well, what it is, let's see, sine, cosine, tangent, cotangent, secant, and what? Cosecant. The secant is the reciprocal of the what? The cosine, Hubert. That's right, class. So let's find the cosine. Cosine of theta is equal to, Oscar had a hunk. which is going to be equal to A is the square root of 25 minus B squared over, I just had a brain bubble, 5. Well, we don't want the cosine, we want the secant. So the secant of theta is equal to 5 over the square root of 25 minus B squared, and just put your inverse sine right there beside it, inverse secant. And that's, the secant's supposed to be over here, but I run out of room. Is this a test question? Hail to the yeah. This is a review question for Trig. You should know how to do this. The only difference is what you're used to is this is usually a what? The adjacent is usually a what with the questions you're dealing with. Okay, since y'all are not going to, this is usually a number. And since it's not a number, you're supposed to sit there and eventually quit. Right?
Yep.
When the tough get going, what do you do?
Quit.
Go home.
Quit. There you go. You're learning. And that's the 3 questions sent. I hope that helps.
On the second one, do you still have the calculator up?
On the second one. Yeah.
I think when you put it into the calculator, you used x squared for the denominator. And it's supposed to be just x.
Did I type it in right? Should be x, shouldn't it?
Yes.
Well, they got the wrong answer. The wrong answer, they had the answer as x squared. They need to fix that question. I thought that x canceled. Go back and look at that answer and tell me that they have, oh shoot, the heck with it. Let me pull it up for you. I thought that x canceled. All right, where is 140? Second one. I can't remember. I think this one is it. No, yeah. That's an error because that question, the x does cancel, because I remember looking at that x and that x squared. That says x squared. It's supposed to be an x.
Yeah.
They need to fix this question. That's not right. That should be an x.
So
let me wait. Let me wait and hear from them, and then I'll do it when I hear from them. They're gonna send me. Hold on. They're gonna send me 5 or 6 case numbers. They do that. I don't know why they just don't answer the dang question. They send me a case number, and then they send me another email that says, "Oh, we're going to get to it. Why don't you just send me one email?" It's a conspiracy. All right, I'll get back to that question. I want to move on. All right, what I want to move on to, y'all did get, I look and make sure that you got your exponential laws, your logarithmic properties. I put them on all one sheet. Your unit circle and your sine, your basic sines and your basic derivatives. I meant your special angles and your basic reciprocal identities. Okay, now I'm going to try to get through to 2.4 today, or 1.4, because we need to get into chapter 2, because that's where most of your test is, your unit 1 test is going to come from, chapter 2. So make a note of that. So let me move on. We know that there's a couple of things I want to put on that, and I want you to make sure you make a note of right here. Make sure you make a note of the two that I have in red. Okay, because some people forget about those. Okay, you've got these. These are on the handout that I sent you before class. But these two red ones right here, you need to remember both of these. Because this one you usually forget. It's called the equality, and it's also good with logarithms. If the bases are the same and the exponents are different, then you can set the exponents what? Equal to each other. For instance, if I gave you 2 to the 4th is equal to 2 to the 2x, then there I can say 2x is equal to 4 and x is equal to 2. Okay? This one people forget, and they also forget it in logarithms. This one, people see that e to the x, and what is y'all's automatic reply to e to the x? What do y'all do when y'all see e to the x on a test?
Natural log.
Well, actually, most people freak out and skip it. Why? Because e to the x looks like it's what? Complicated, but it's not. It's not complicated, it's just a number to the x power. So those are the two things I want you to be aware of. Also, be aware of the graph. Be aware of the graph is on your family of graphs. The green one usually is when b is greater than 1. That's an increasing function crossing at 0 and 1. That's the key. When you see that 0, 1 right there, that means they're talking about exponential. So make sure you make a note of that. Also make sure, this is kind of a review, what undoes a function? The what function?
Inverse function.
The inverse function. I want you to be able to graph the inverse function. I want you to be able to find the inverse function algebraically. Let's do this one as an example to knock your cobwebs loose. F of x is equal to x squared. I want each of you to find the inverse function of that. If you can't, just sit there and stare at it, because we'll do it in a minute, all of us. Not that any of y'all would be sitting there staring at it confused, but. Y'all not being very talkative today. What's up with y'all?
It's a gloomy, rainy day.
It's because we
That's
suck.
the best day. It's movie day. Movie and old-fashioned day. You just drink old-fashions and watch movies. Until you just sitting there slobbering on yourself.
I forgot how much class time we used to waste discussing movies.
Waste? What do you mean waste? That's derogatory about my class, thank you. We didn't waste time. We filled in gaps. How about that?
Alternatively implies that the time not spent talking movies was not a waste.
Exactly. It hurts my feelings. Miss Sterling likes to hurt my feelings. It makes her day. All right, what's the first thing you do? Well, you get rid of the pinky mess. Change this to y is equal to x squared. Then you flip them.
Swap
X
and
is
y.
equal to y squared. And now solve for what?
Y.
Yeah, y.
Y is equal to the square root of y. I'm sorry. Y is equal to the square root of x. Now, Don't write y, write y to the -1. Bring the pinky back in. F of -1 of x is equal to the square root of x. So the inverse function of x squared is square root of x. So if you graph x squared, that sounds like somebody coming into a store. There's y is equal to x squared. And the inverse function, I'm going to do it in red, is the hyperbola. And what do they have in common? You're going to see some kind of symmetry around that 45-degree angle. Make sure you can do this, and make sure you can do it on your calculator. Well, at least picture it. Sometimes you can't do the inverse. I don't know. I don't fool with calculators, so I don't, especially that one I got on here. It's not very good. I'm going to do one more. Let's do f of x is equal to f of x is equal to x to the 4th plus 1. All right, do that one. You can do those two. You can handle any that I give you.
We're finding the antiderivative, right? I mean, the inverse, right?
I want you to find the inverse function.
Okay.
So, drop the pinky. You get x to the 4th plus 1. Switch. X minus 1 is equal to y to the 4th. 4th root of x minus 1 is equal to f of -1 of x. And you should be able to graph both of them. Yeah, you can do the inverse on both of these, yeah. Okay, so that would be x to the 4th plus 1. X to the 4th plus 1. You know from your family of graphs that the higher up your even exponent is, the more squared your bottom is. That don't sound right, but instead of a parabola, it looks more like a what? A U. The higher your degree on your even function, the more squared your bottom is. And of course, the other function would look something like this. I've got a little bit drawn off center of but the 45-degree angle is right in there. Usually there will be a symmetrical 45-degree angle somewhere in your functions. I mean, on the graph. Feel good?
Yep.
Logarithmic function. Logarithmic functions. Make sure you understand one of the most important things about the logarithmic functions, and that is the first one. Definition of a what? Definition of a logarithm.
I mean, I don't know it off the top of my head.
It's right on.
Huh? What? What'd you say, Miss Sterling?
I don't know it off the top of my head.
Well, then you're probably going to fail this class.
Yeah, I know I suck.
There you go. At least you know it. Just like AA. As long as you know it, it's a good thing. Definition of a logarithm. You not only need this with simplifying, you need it with solving equations with logarithms. So make sure you write that down. That's your first property. If you have y is equal to the log of something, you can change it into a exponential. If you have an exponential, you can change it into a logarithm. And as Miss Hart said, the inverse function of e to the x is the natural log of x. So you were correct, Miss Hart. It just wasn't the right time to say that back then. Okay? The inverse function of e to the x is the natural log of x. And you see, this is e to the x, and this is natural log of x. Don't forget your product rule, your quotient rule, and your power rule. Now, these are all things you should remember. We are still in review with Chapter 1. We don't get to limit theory until Chapter 2, so you're still in review mode. We got to get you out of review mode. We got to get you into Chapter 2 as soon as possible, so we can discourage you and get you to drop. Question. Make sure you send me questions. If you don't send me questions, I'm going to assume that you what?
Know it.
Assume that you know it. Now with trig, don't forget the trig. Now I gave you what you should know on the handout, but make sure you can do basic trigonometric functions. I give you theta right there, and I give you a 2 here and a 5 here, and I tell you to solve the 6 trigonometric functions. Make sure you know that this is going to be 5 squared. This is going to be a squared is equal to the square root of 5 squared, which is 25, minus 4. Y'all check me. A squared is equal to the square root of 21, which I'm going to just leave it the square root of 21. Even though 25 is 5, so 21, I don't know, 4.5, 4.4. Somebody give me the square root of 21. What is it? What's square root of 21?
God, I know this.
4.58.
Are you referring to 3 square root of 3 or?
Or you want me to like
Square root of 21. What is it? Just a decimal.
No, that's
4.58257.
4.6 is good enough. Miss Sterling, I'm going to pick whatever is opposite of what you're giving. 4.6. So therefore, sine, cosine.
Hey, I'm not teaching for a reason.
And I can't hear you. Sine, Oscar, had, a, honk, of, apple, Oscar is the opposite, is always opposite of there. Your little man is always on alpha. So therefore, his foot is on the adjacent and the hypotenuse. So the opposite is the only one left. So that's going to be 2 over 5. And adjacent is 4.6 over 5. And the tangent is 2 over 5. And of course, the cotangent would be 5 halves. The secant would be 5 over 4.6. And the cosecant will be 5 over 2. I'm going to let y'all do those. I'm not going to do those because this is a review. You should know how to do that. Make sure you know your special angles. What did I do with that?
As part of the logarithm review, I just sent you another question.
Okay, good. Let me get to it. Give me a second.
It's in the chat.
Oh,
That's a different question.
Oh, just kidding. Yep.
oh, well, let me see the question you sent. And I wasn't on the chat. I'm sorry. I was on how many people are in the classroom. Okay, f of x is equal to 2x. I want it to go down, see more. F of x is equal to 2y? Where did you see that one? Two y times that's not right. Okay, let me go to his question. Hold on. Let me go to his question. We'll come back to that one. You can't have y is equal to 2y. You got to solve for y. Okay, we'll get to that in just a minute. I'm trying to get to the other question. Mr. Quinn, did you send it?
Yes.
Okay, cover this in class. Let's see what this one is. Oh my Lord. T-Rex on the hill. Whatever. I'm waiting. 15 minutes later. Okay, convert the following expression to indicated base using base 5. Oh my Lord. Well, first of all,
doesn't have the show me.
It doesn't have help me solve this, does it?
It does not.
Where do these questions come from? Okay, I'll have to do that one here at home because you're going to have to set it equal log base 3 of A and change it to base 5. You're going to have to use the change base formula. Let me, okay, 2F. Okay, I'm not going to do 2 questions at one time. Yeah, let me do this one and undo this one for tomorrow because that is not a good question. I mean, I'm glad you sent it, but I remember this question from last semester. I had to do this one, and I got to look back in my notes because I remember this question. Something you don't do a lot of right here, but I'll address that question when we come back. Okay.
Okay.
All right. Now, your question says 2F. That ain't right either. Where do you get this question, Miss Sterling?
Homework question 1.2.56.
Send me the question. Send it to me right now. Y'all have one job. Your one job. You only have one job, and that is to hit the button. Y'all can't do that job. I'm going to go ahead and print that question out for Mr. Quinn because I'm going to have to find. I did that question.
I considered sending it to you earlier, but even the textbook was not helpful on answering that one.
Did you send it, Miss Sterling?
Yes, I did.
Okay, I did that one. What? Okay, let me print Mr. Quinn's off right quick. And then pull yours up. Yeah, they don't even have Ask My Instructor. I mean, they don't even give you the. How did you send it to me if it wasn't? Did you send it to me through Ask My Instructor?
Yes, I did.
I was talking to Mr. O'Quinn because it didn't have it right there. All right, let me go to yours now. I think that's 2f of 3x minus 4. I've never seen 2f times 3x minus 4. Okay, first of all, use shifts and scalars to transform. Okay, this is a test question. You sent a good question. All right, so f of x, let me get my handy dandy visualizer up. So f of x is equal to the square root of x. F of x is equal to the square root of x. We know family of graphs tells us that it looks like that. Okay, everybody with me? So that's what the family of graphs tell us, the square root of x. Now it says g of x is equal to f of x plus 2. So that means that we're going to plug in x plus 2 to the what? To the function. So g of x is equal to f x plus 2. So that means I'm going to rewrite that radical with a big set of what? Parentheses, and I'm going to plug in x plus 2, which means this is a horizontal shift of 2 to the left. So that means that my graph looks like that. Now it says g of x. Okay, now I see where your question is. B says, that's A, g of x is equal to 2 times f of 3x minus 4. So now I'm going to rewrite f with a big set of parentheses. And I'm going to plug in what? I'm going to plug in 3x minus 4. And that should give me a horizontal shift of 4 to the right. It's 4 to the right.
It says that's wrong.
What does it say, shift to the right then?
Correct answer says shift 4/3 units to the right.
Got to factor out the third.
Because you got to factor out the 3, that's why. Okay, let me redo it. They're doing it, okay, they're factoring it out. So that's going to be square root of 3/4, or the square root of 3, parentheses, x minus 4/3.
We can't see what you're doing.
Sorry. So that's equal to 2 brackets, the square root of 3 times x minus 4/3. So that would be a horizontal shift of 4/3 to the right. And you can't distribute among this. So this would be, you're going to be at a skinny. So it's going to be compressed.
Is it gonna
What?
Is it gonna compress it twice? Once for the 3
Yep.
and then once for the 2?
Yep. So that's going to be 4/3 is what, 1 1/3. So that's going to be right here, and it's going to compress it with the 3 and compress it. So it's going to look something like that. I mean, it's going to be compressed. And x minus 3 would be 3 to the right. And here would be 3 to the right, 6 down. So I'm going to do D. I'm going to do D for you. D says 2 x minus 3 minus 6. That's a horizontal shift of 3 to the right. This is a vertical shift of 6 what? Down. And this is compression. So you've got 3 to the right, 1, 2, 3. 6 down, 1, 2, 3, 4, And it's going to be compressed. It's going to be like that. I'll be honest with you. I like the question. I don't like the way that they have the 2f times 3x minus 4. To me, that's a little bit misleading. But I like the other ones. I like the other questions. Those are good questions. Okay, I will get your logarithm question done as soon as possible. And then we'll present that first at the next. Make sure, I was going to go over your, I know I'm out of time, but I wanted to go over one thing right quick that you're going to have to know. And that one thing is your special angles. 30 degrees, 45 degrees, and 60 degrees. Okay? 1/2 square root of 3 over 2. 1 square root of 2 over 2. Well, I don't like to do it that way. That's not the way I do it. They're already doing the sine and the cosine. All right, that's going to be 1 square root of 3, 2, 1 square root of 3, 2, 1, 1 square root of 2. Make sure you can do the sine, cosine, and tangent of all of these. I'll do the first one for you. Sine, cosine, tan, cotan, secant, cosecant. Because this is how you do your unit circle, unless you want to memorize it. And I don't tell students to memorize it because that's a pain. Okay? So Oscar had 1/2. A hunk square root of 3 over 2. Of apple 1/2. 2 over 1. 2 over square root of 3, which is equal to 2 square root of 3 over 3. And 2 over 1, which is 2. Now make sure you can do that with your special angles. Okay, it's already 4:30. All right, I need y'all to turn your microphones on, and please answer me whenever you hear your name, because I don't want to have to go through it again, please. Okay, attendance tracker. Oh my Lord. I done figured out how to do it. You have to log out of everything. And you have to pull up. This is so. It's a conspiracy. You run over by a car. The person that's driving the car has corona, so that means you died of corona.
Sounds about right.
Yes, but also no.
No, it is that this whole corona thing it's got dirty written all over it. But it's not China's fault. It's not China's fault. China did nothing wrong. China's an angel. China, just like the Taliban, they slit your throat in a heartbeat if they could. As soon as people realize that, shut up, Hubert. Shut up. Attendance tracker. I'm sorry. Oh. Let me call up Firefox, and I'll just bear with me a minute. I don't know why I have to do this every time I go to the attendance tracker. I have to go to Firefox to pull up the attendance tracker. It takes an hour for Firefox to come up.